Hello students, in the last lecture I discussed about the topic problems encountered in measuring a living system, and under this topic I discussed three problems, that is inaccessibility of variables, variability of data, lack of knowledge about interrelationships. So in my previous lecture I discussed about these three problems. In this lecture I will be discussing rest of the problems that a biomedical engineer will face while measuring a living system. So these were the three: inaccessibility of variables to measurement, then variability of data, then lack of knowledge about interrelationships. These three topics I discussed in my previous lecture. So the next problem that one may encounter while measuring a living system is interaction among physiological systems. So what happens inside a human body? We know we have physiological systems inside a human body. There are physiological systems like a cardiovascular system, respiratory system, nervous system, etc. So inside a human body you'll get to see a number of feedback loops are there. So these feedback loops might be present within a physiological system, or it may be present between the physiological systems. So there are a number of feedback loops inside a human body. Now because of these feedback loops, what happens? We do not get to study the cause and effect relationship, which means suppose in a physiological system I need to study the characteristic, or I need to study the behavior of a certain organ. I need to study the behavior of an organ inside any one of the physiological system inside a human body. Now for studying that organ, what I'll be doing, I'll be giving some stimulus to that organ, and because of that stimulus I'll see the behavior of the organ. So this is cause effect relationship. You are giving some stimulus and you will record the result. So this is cause effect relationship. So while doing that, when I give a stimulus to an organ whose behavior I want to study, what will happen? Because of that stimulus, not only that organ will get affected, but the other parts of that physiological system will also get affected, because there are feedback loops present inside the physiological system. Moreover, many a times other physiological systems also do get affected because of the feedback loops present between the physiological systems. So due to this, the cause effect relationships become extremely unclear and difficult to define. Moreover, you will also get to see there is one more problem in this topic only I will be discussing. There is one more problem. Sometimes what happens, one of the organ fails inside a human body. So I am just telling you the complexity of human body. What happens when one of the organ fails inside the human body, or it is rendered inactive? What happens? Another organ or element takes over the function. So this type of situation can be seen in the brain or other parts of the nervous system. So now you can see how complex is the human body and how complex it is to measure any variable, any physiological variable inside a human body. So this is what I have discussed: interaction among physiological systems. Next is effect of transducer on the measurement. Now generally in any measurement system, or you can say while in any kind of measurement gets affected by the presence of or by the introduction of a measuring transducer. So when you are introducing a measuring transducer to measure something, the result might get affected because of the introduction of that measuring transducer. This is the general case. So this gets multiplied while measuring any physiological variable for living system. How? Let me give you an example. Suppose we want to measure the flow of bloodstream inside a human body. So for measuring the flow of bloodstream inside the human body, what we need an instrument. We will need a transducer. So many times the physical size, or you can say the physical presence of the transducer, will affect the result. So suppose the transducer that I have placed in the bloodstream, it is a large, that is a flow transducer obviously, but that is a large flow transducer. So what it will do, it will block the vessel in whose blood I need to measure using that transducer. So the vessel inside which the blood is flowing, I need to measure the flow of that blood inside that vessel using the transducer whose size is actually large. So what that transducer will do, it will partially block the bloodstream, and it will affect the pressure flow characteristics of the system. Ultimately we won't get the actual result. So this is how introduction of a transducer or a measuring device can affect the results. One more example let me give you. Suppose there is a cell, living cell inside a human body only I am giving. There is a cell, and in that cell you want to measure the electrochemical potential. So for measuring the electrochemical potential of the cell, what you need to do, you need to insert a transducer inside that cell. So while this penetration can easily kill this living cell and damage it, so that it can no longer function normally, and ultimately we won't be able to get the actual result. So these were the examples that I have given you, how the introduction of a transducer is affecting the measurement in a living system. So one more case under this topic I would like to discuss is the physiological effect, that is fear response on the part of the patient. What does this mean? What happens, it has been seen through this long-term recording technique, which is actually recording the blood pressure of a patient. It has been seen through that recording that the individual's blood pressure is actually normal, but while he visits the physician's clinic, his blood pressure gets elevated. Why? Because of the fear response on the part of the patient. So this psychological effect it also affects the result, or it also affects the result of the measuring system for human body, used for human body. So for designing a measurement system for the human body or for the living system, the biomedical instrumentation engineer, they have to exert extreme care to ensure that the presence of this measuring device, or you can say the presence of the transducer, the effect of the presence of this transducer is minimal on the human body. Moreover, the transducer or the measuring device, it should also not introduce the loading effect because of the limited amount of energy available in the body for many physiological variables. Biomedical engineer has to exert extreme care to devise the device in such a way, to devise that instrument or to devise the transducer in such a way that it should not introduce loading effect, or it should not load the source of the measured variable and extract the energy from it. So this was the effect of transducer on the measurement. Next I am going to discuss, I am ending this lecture here. I will be discussing the rest of the three problems in my next lecture. The remaining are artifacts, energy limitations and safety considerations. So I will be discussing these problems in my next lecture. I am ending this class here. Thank you.